Good afternoon, students. You are able to listen to my voice?
Voice.
Okay. Yesterday we have completed the second unit. Okay, today we'll go to the third unit. Third unit is about the special methods. That is the methods of differentiation. Okay. So methods of the differentiation is why we are using the special methods to do the differentiation is because some of the functions will be there which we cannot means with the direct principle. First principle is there, no? With the help of the first principle, we can't find the differentiation of those functions. So to do the differentiation of such functions, we use some special methods. Okay. Yesterday I have given the second unit important questions, no? So you collect from the other students. Okay. Already I have given the important questions in second unit. So starting, I have told the definition of the differentiation. That is in the page number 29. Okay. And after that, page number 30 also you have the definition. And also what is RHD and LHD is there. And page number 32, 33 and 34. 34 2.2.11 theorem is important. Okay. 34 page number 2.2.11 theorem. And after that, further theorem example problem is on page number page number 35, and it is 2.2.12. Okay. Example, that is f of x equals to mod x. So this you might get for 10 marks question. And 36 page number, you have 2.2.14, 2.2.15 and 2.2.16. And fourth, check your progress. I have told that problem. And one thing is that fourth question, show that f of x equals to mod x plus mod x minus 1 is derivable. It is given. Actually, the question should be is not derivable. Okay, if we'll see the answer for this also, there it will be not derivable. But the question is given as it is derivable. Okay, so it is not derivable at x equals to 0 and 1. You correct that one. So for 2.2.14, 15, 16 questions. These you might get for that is a 10 marks question, 9A or 9B. So almost 9B you will get these questions. So of f of x equals to x square sine 1 by x. This is the 5 marks question. And next you have 2.2.15 x tan inverse 1 by x for x not equals to 0 equals to 0 for x equals to 0. Okay. That is you have to find the RHD and LHD pi by 2 and minus pi by 2. Just you substitute the 0 minus h and 0 plus h. And you remember the values here. For RHD, you will get pi by 2 and for LHD, you will get minus pi by 2. Okay, if you write that, it's enough for that one. And 2.2.16 is x sine 1 by x is there. Here, what it means that sine x is always, it lies in between minus 1 and plus 1. Okay, so one value you have to show it is continuous and also it is not derivable. So sine x is continuous, but here the derivability will not exist. So this you might get for 10 marks question. And also check your progress. Fifth question is there, no? Examine continuity and differentiability of f of x equals to 1 plus x and 5 minus x. Okay. So these are the important questions in second unit. So one theorem is there and whatever the problems now I have told those. And one problem we have done from MEQ yesterday. That is for the point 0, 1 and 2. That is also the 10 marks question. So now we'll go to the third unit. So third unit, in this all the methods are there. So before the methods, yesterday I have given all the formulas of the trigonometric functions, and also different functions we have seen the formulas. So here we have the that is the trigonometric functions, and also hyperbolic functions are there. So 54 page number, 55, 56, 57, 58, 59, 60, 61. So up to 61 page number. Almost I have given all the trigonometric, but I have not given the hyperbolic inverse trigonometric function formulas. So you collect all the formulas from the textbook. So if you know the formulas, then only we can solve all the problems here. So try to practice and by heart those formulas. Okay. Now we'll go to the special methods of differentiation. So why we use the special methods? Because some sort of functions will be there which cannot be differentiated with the help of the first principle. So to differentiate such functions, we use the different methods. So for different, in this also different functions will be there. Okay. In this also some different functions will be there. For that functions, different methods will be there depending on the given functions. So 4 methods will be used for the 4 different type of functions. So in that, first we see the substitution method is there. So substitution method, we generally we take the, that is x value as the sine theta or cos theta or tan theta. In place of x, we substitute that one. And one thing is that the given function will be in the somewhat complicated form. We convert it into the simple form and then we do the differentiation. Okay. So that is about the special methods. Okay. First one is the substitution method. So substitution method is that we use the trigonometric or any algebraic transformation. So algebra, any transformation will be there, no? So either that one or in place of x, we'll take any type of the trigonometric function and we'll convert it into the simple form. And one we have seen the example, that is y equals to sine inverse of 2x by 1 plus x square. This is one 5 marks problem. Okay. So here, if we'll do normal differentiation, what will happen? It is dy by dx equals to, it is in the form of sine inverse x. If whole thing, if you'll take it as x, so differentiation of this, you will get it as dy by dx equals to sine inverse x differentiation is 1 by root of 1 minus x square. Okay. So here x, you have 2x by 1 plus x square. That means it is equals to 1 by root of 1 minus 2x by 1 plus x square whole square. Okay. Now you have to expand this one and then you have to do the simplification of this one. Okay. So that is the lengthy process and also complicated one. So to convert this into simpler form and to do the differentiation, we'll substitute here x value as a tan theta. Okay. Yesterday I have given the formulas. So if you remember that, so when you keep here x as tan theta, what will happen? Here put x equals to tan theta. So y will be sine inverse of 2 tan theta by 1 plus tan square theta. So this is, if you see the formula, this is the sine 2 theta in terms of tan theta. So it is equals to sine inverse of sine 2 theta. Okay. Now you can take this as a equation 1. Now differentiate 1 with respect to x on both sides. Here, if y equals to, question will be like this. If y equals to sine inverse of this one, then find dy by dx. Okay. So when you differentiate this, you'll get dy by dx is equals to, and even here you convert this one, sine and sine inverse and sine inverse trigonometric function and trigonometry both will get cancelled. You'll get it as 2 theta. So 2 theta equals to 2 into, here we have substituted x equals to tan theta. From this, theta equals to tan inverse x. Okay. So here you substitute in place of theta tan inverse x. Now you take this as 1. Okay. So y is equals to 2 tan inverse x. If you differentiate, you will get dy by dx equals to 2 into tan inverse x. What is the differentiation of tan inverse x? it is 1 by 1 plus x square. So that is 1 by 1 plus x square. So differentiation of this one is dy by dx equals to 2 by 1 plus x square. So like this, you have to convert it into simple form and then you have to do the differentiation of that one. Okay. So this is about the substitution method. In substitution method, we'll see some examples are. So in your textbook, other questions are also given based on this one. So if we'll go to the next one. So one more question is y equals to sine inverse 3x minus 4x cube is there. Okay. So this is also, if we'll do direct differentiation, what will happen? Dy by dx equals to sine inverse means 1 by root of 1 minus 3x minus 4x cube whole square we have to do. Okay. So that is a very lengthy process and also complicated one. So to make it into simple form, we'll convert here. That is, we'll put x value as sine theta here. Okay. So here substitute x equals to sine theta. So what will be theta? Theta is equals to sine inverse x. Okay. So when you substitute here, what will happen? Y equals to sine inverse of 3 sine theta minus 4 sine cube theta. Okay. So if you remember the formula for this one, 3 sine theta minus 4 sine cube theta means it is sine 3 theta. Okay. So sine inverse and sine both will get cancelled. You will have only 3 theta. So y, it is equals to 3. What is theta from here? Sine inverse x. Now you can take this as 1. So differentiate 1 with respect to x on both sides. So y differentiation is dy by dx and 3 and sine inverse is 1 minus x square. 3 is the constant one. You keep like that only. Sine inverse x differentiation is 1 by root of 1 minus x square. So the differentiation of this one is this. Here also you write if y equals to this, then find dy by dx. Okay. The question will be like this. So problems will be like this only. Inverse trigonometric functions, or normally they will be in the form of cos theta equals to root of 1 minus x square by 1 plus x square, like that, or some algebraic expressions will be there, or else they will be in the trigonometry. So such one, to make it in the simple form, you have to substitute either x equals to sine theta, cos theta, or tan theta, depending on the given problem. But the thing is, you have to make it in the simple form, then you have to do the differentiation. Okay. So this is one problem, and one more is, so you will have like this, y equals to cos inverse of 1 minus x square by 1 plus x square. Okay. So 1 minus x square by 1 plus x square means here cos inverse is there. That means cos should be get cancelled. So that means you can keep here x as tan theta. So cos 2 theta in terms of the tan theta, we have to convert that one. So now substitute x equals to tan theta. So if you know the formulas, then you can solve this easily, because put x equals to tan theta implies theta equals to tan inverse x. So what will happen? Y equals to cos inverse 1 minus tan square theta by 1 plus tan square theta. Okay. Now it is cos inverse of, this is cos 2 theta. Okay. So cos and cos inverse both will get cancelled. 2 theta will have, and it is 2 tan inverse x. So if you take it as 1, differentiate 1 with respect to x on both sides. So what you will get, y is dy by dx is equals to 2, and tan inverse x differentiation is 1 plus x square. So our required dy by dx is this one. Okay. So these all, whatever the substitution method is there in this method, only 5 marks questions you will get. This is about the substitution method. And if you see the important questions in this 62 page number 3.4.2 and 3.4.3 is the important one. This is the 5 marks question. So these two problems you practice. Okay, already solution is given in the textbook. Here for the 3.4.3 problem, you have find the derivative of y equals to tan inverse of root of 1 plus x square plus root of 1 minus x square. So tan inverse is there. So here you are substituting the value of x square as cos 2 theta. Okay. So if you substitute here x equals to sin theta or cos theta or tan theta, root is there. So that's why it will not get cancelled. So you take it as cos 2 theta. So y equals to tan inverse of root 1 plus cos 2 theta plus root of 1 minus cos 2 theta is there. And if you'll see the cos 2 theta formulas are there. I have given the 3 to 4 formulas. So in that 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta. So that's why if your root is there, no? So this both root and square will get cancelled. You will get cos theta plus sin theta. And in the denominator, cos theta minus sin theta. Okay. So it is equals to tan inverse os. How you got 1 plus tan theta means here you take out cos theta common outside. So cos theta plus cos theta plus sin theta is there, no? So you take cos theta. If you take common, you'll get 1 plus sin theta by cos theta. Then it will become 1 plus tan theta. Okay. So you see the 3.4.3 problem. Then tan inverse of, here tan inverse is there. That's why you have to convert that in the form of tan. So it is tan pi by 4 plus theta. Tan a plus b form it is there. If you cancel out tan and tan inverse, pi by 4 plus theta will be there. And if you do the differentiation of that, you will get the answer. Okay. So that is the 3.4.3 problem, and 3.4.2 is simple one. If you substitute the tan theta, it's enough. Both you will get the tan and tan inverse will get cancelled. You will get tan, that is only 2 theta. Next, if we'll go to the logarithmic differentiation. So for which type of problems we'll use the logarithmic differentiation is the functions which are in the form of u to the power of v, where u is one function and also v is another function. If both are the functions which are in the form of function to the power of function. So such type of functions you can't do with the help of the direct differentiation. You have to use the method of logarithmic differentiation. Okay. So while we have seen the formulas, you have seen the formula for e power x and also even a to the power of x. So e to the power of x differentiation is, you will get e to the power of x, and a to the power of x means a to the power of x log a. And if you see x to the power of n into x to the power of n minus 1. Okay. So you have the formulas for these all such type of functions. E power x is there, a power x is there, x to the power of n is there. But you don't have a formula for x to the power of x. Okay. Variable, that is function to the power of function here. So such type of functions will be solved with the help of taking the log, taking log on both sides and then converting it into simple form, then doing the differentiation. So such type of functions you are doing with the help of the substitution of, that is the next method is logarithmic differentiation. So here you can take the example of, so in this, if only one function is given, you will get the problem for only 5 marks. If you have the combination of 2 or 3 functions, means x to the power of x form will be there, but they will be means 3 functions, different 3 functions will be there, and it will be combined and given as a one question. So then you will get it for 10 marks question. If simple one is given like this, if you'll see, find the derivative of cos x to the power of log x. Okay. Cos, it is in the form of x to the power of x. So here in the solution, you take let y equals to, here y is not given, just the function is given. So you take y equals to cos x to the power of log x. Okay. So now it is in the form of x to the power of x or u to the power of v. So now taking log on both sides, or you can write taking logarithms on both sides. Okay. In short form, we are writing here taking log on both sides. What you will get, log y is equals to log of cos x to the power of log x. Okay. Now it is in the form of log x to the power of n. So log x to the power of n is n into log x. This formula we are applying here. Okay. So log x to the power of n. So you will get it as log x into log of cos x. Okay. Here it is log y. Now you take this as equation 1 and differentiate 1 with respect to x on both sides. So differentiation of log y. So log x or log y, anything. Log y differentiation is 1 by y. And if other than x, if you have any variable, you have to write the differentiation of that one. Okay, remember that. Y differentiation is dy by dx is equals to. This is in the uv form. That is, this is u one function and this is v another function. So here we have to apply the uv rule. So you take this as a constant. U, if you will take constant, log x is constant, and do the differentiation of this one. That is log whole thing, you take it as x. So log x differentiation is 1 by x. Here x is cos x. Okay. And here we'll write actually x differentiation as 1 here, but instead of x we have cos x. So cos x differentiation is minus sin x. Okay. So log x 1 by x and x differentiation is minus sin x. Okay. Now this is u constant, v differentiation plus now v constant you keep, and differentiation of log x is 1 by x. Okay. So it is equals to, now just you simplify this, log of minus sin x by cos x is tan x. So minus you take outside. So log x into tan x plus 1 by x into log of cos x. Okay. Here you can write this as dy by dx is equals to, you take this y, this side, right hand side. So it will be y into this one. And what is y from the given question we have taken here? Y is equals to cos x to the power of log x. So it is cos x to the power of log x. Here minus is there. So just you can write like this, 1 by x log cos x. Okay. Minus log x into tan x. Okay. This is the procedure how to write the, by taking log, you have converted it into simple form, then we have done the differentiation. Okay. So this such type of problems you will get for the 5 marks question. Now one problem we'll see for the 10 marks one. So 10 marks problem also, how means you can do direct differentiation taking y and direct to whatever the two functions are there. You can take them and you can do. If not, you can take one function as u and another function as v, and we can do separately. Okay. So that is also one method is there. So we'll take the example of that one. Okay, if you'll see here, the y equals to sin x to the power of log x plus x to the power of x. So the question is this one. So it is from the MBQ questions are there. So from that we are taking this question. Y equals to sin x to the power of log x okay, plus x to the power of x. So now we have to find dy by dx of this one. Or the question will be in the form of find the derivative of sin x to the power of log x plus x to the power of x. Okay. So here if you have, if y equals to this, then find dy by dx or derivative. The question may be in any form. Okay. So for this one solution, first thing is we are taking here y, we are given that y is equals to sin x to the power of log x plus x to the power of x. Okay. So we'll take let u equals to, two functions are there, no? So you take let u equals to this one, first one, that is sin x to the power of log x, and v equals to x to the power of x. Okay. So then what we'll have then, y equals to u plus v. So now it is in this form. Now if you differentiate this one, differentiating on both sides with respect to x, what you'll get, dy by dx is equals to du by dx plus dv by dx. Just we have differentiate this one. So dy by dx, this one is equals to du by dx plus dv by dx. Now we need these two values. If you do the differentiation of these two and if you substitute here, then you will get the differentiation of this one. Okay. So first we'll take u equals to, so take u equals to sin x to the power of log x. Okay. So this is in the form of x to the power of x. So taking log on both sides, what you'll get? We get log u equals to log of sin x to the power of log x, this one. So again applying the same formula. So log to the power of this means log x into log of sin x. So this is u and this is v. Or take anything, pq or anything. Why? Because already you have taken u and v. No, now it is in the form of uv, and this is log u. Now you differentiate this one. You take 1. So differentiate 1 with respect to x on both sides. So what you will get? Log u means log u differentiation is 1 by u, and u differentiation is du by dx. Okay. So it is equals to, this is u and this is v. So you are taking this as constant. So log x keep constant and find the differentiation of this one. Log, you take this as x. So log x differentiation is 1 by sin x into, what is sin x differentiation? Sin x differentiation is cos x. Okay. So this is one part. Next one is log sin x, you take like that only. And what is log x differentiation? 1 by x. Okay. This is 1 by x. Now if you simplify this, so du by dx is equals to, you take u this side. So u into, what you'll get, log x into, this is cos x by sin x. Cos x by sin x is cot x. Okay. Plus 1 by x into log of sin x. Okay. So now what is u here? U is sin x to the power of log x. So you write here sin x to the power of log x into this part. Okay. Whatever in the above is there, you write that one. So this is our du by dx. So this you can take it as 2. Okay. So this is the second equation. Now we need to find dv by dx. So now v is equals to x to the power of x. Okay. So differentiate 3 with respect to x on both. So first we should take log, no? So taking log on both sides, taking log on both sides, what will happen? Log v is equals to log of x to the power of x. So it is x into log x. Okay. So this is log v. Now you take this as equation 3. Now if you differentiate this one, so differentiating 3 with respect to x on both sides. So log v differentiation is 1 by v into dv by dx. Okay. In differentiation, remember that if you have the variable other than x, you may have u, v, w, or z, or y, anything. So you should write compulsory in the form of dy by dx. So here with respect to variable we are doing, so dv by dx. So why we are not writing for x variable? Because it is in the form of dx by dx and that value is 1. Okay. So that's why we'll not mention that. So here, this is again in the form of uv. Okay. So you take x as constant and log x differentiation is 1 by x plus log x you take constant and this x differentiation is 1. So it is equals to xx, both will get cancelled, 1 plus log x. Okay. Here dv by dx is equals to, you take this v this side, this is v into this one. And what is v? V is x to the power of x, 1 plus log x. Okay. Now we got both that values. You take this as 4. Okay. Substitute, after that you write substitute 2 and 4 in 1. Okay. That is in dy by dx. So what we have dy by dx? Dy by dx is equals to du by dx. This is the value du by dx. So sin x to the power of log x. Okay. If not, I will write here. Dy by dx is equals to sin x to the power of log x plus x to the power of x into 1 plus log x. Okay. This is the dy by or the derivative of the given function. Okay. This is the answer of that one. So like this, if we'll find the solution whenever the two functions are given in, that is combination of 2 x to the u to the power of v functions are given. Even in some case, you will have 3 also. Then you have to take u plus v plus w. And then you find u separate, v separate, and w separate. Then you add how you have added here as dy by dx equals to du by dx plus dv by dx. Next, if you have the third one, it is the dw by dx. Okay. Then if you just add and if you take dy by dx, that is the answer of that one. Okay. So if you do the procedure like this and combinations are given in such a way 2 or 3, so you'll get the question for the 10 marks one. So in this third unit, the 10 marks question is from the second method, that is the logarithmic differentiation. Next, if we'll go to the third method, it is the parametric differentiation is there. So far we have seen the functions which are expressed in the form of y is equals to f of x. So we have seen what these all are the functions are in the form of y equals to f of x, but where y is a dependent variable and x is an independent variable. Okay. So in y equals to f of x, y is a dependent variable and x is a independent variable. So what will happen sometimes, the relationship between the two variable x and y will be such that it will be in the terms of another variable. X will be in terms of another variable and y will be in the terms of another variable. So in such cases, we will use the parametric differentiation. Okay. So that is the functions will be in the form of x equals to f of t and y equals to g of t. T is here another variable. Okay. And t is here called as a parameter. And the expressions which are in the form of like this, x equals to f of t and y equals to d of t. So, and where t is the parameter So such type of whatever the functions are called, they are called as parametric functions, and the differentiation of these functions is called as a parametric differentiation. Okay. So here how you will get, for this also we need to find the dy by dx. So how you will get dy by dx means, if you do the differentiation of this is dx by dt, and this is dy by dt. So we need dy by dx now. So dy by dx means you will get it as dy by dt by dx by dt. So this dt and dt both will get cancelled. It will be dy by dx. So first you have to find the differentiation of this x and y separately. Then you divide both. You will get the solution of this one. Okay. This is the procedure for the parametric differentiation. And this is also only the 5 marks question you will get in this. So we'll see one problem on this. So the question will be, if x equals to a cos cube t and y equals to a sin cube t, then find dy by dx. Okay, this is the question. If x equals to a cos cube t and y equals to a sin cube t, then find dy by dx. Okay, so this is the question. So for this, the solution is, first you take x equals to a cos cube t. Okay, you can take this as 1. So differentiate 1 with respect to t. So here the variable is t is there, and this is the variable x. Okay, so with respect to t on both sides, we get, so dx by dt is equals to, now do the differentiation of this one. So this is in the form of x cube. Okay, so y equals to x cube means dy by dx is, it is in the form of x to the power of n. So x to the power of n differentiation is n into x to the power of n minus 1. So here our n is 3, that is 3 into x to the power of 3 minus 1, that is 3 into x square. But instead of x, you have here cos. That means 3 into cos square x. 3 minus 1, no? 3 minus 1 is 2. So it is 3, and this whatever 3 is there, 3 you write as a quotient. So 3a cos square t. Okay. So this is a is the constant here. You keep like that only. This is if you think as x cube. So x cube differentiation is 3x square. So our x is here cos. So cos square t. So 3x square. Now here actually we do the differentiation of x also. Differentiation of x is here 1. But here instead of x we have cos. So cos differentiation is here minus sin t. Okay. So don't stop here only. Another one step you have to do, that is the differentiation of this cos. This is of cos cube t. Okay. So cos cube we have converted into 3 cos square t. And again this differentiation is this one. Here also how it will be there means x cube is there. So 3x square. The differentiation of x cube is 3x square. And again the variable is x is here. So x differentiation is 1. That's why wherever x is there, will not mention here 1 by, because into 1 is the same one, no? So x cube differentiation means we'll write only 3x square. But here we are not having the x value. Here we have cos. So cos differentiation is minus sin t. Okay. So now this is minus 3a cos square t into sin t. Okay. So this is the differentiation of the x equals to a cos cube t. Now if you'll go to second one, y equals to a sin cube t. Okay. You take this as 2 and differentiate 2 with respect to t on both sides. So what you will get? Dy by dt is equals to, same similarly how we are done here, same one. So 3a sin square t, and again sin t. Sin t differentiation is cos t. Okay. Now we need dy by dx. Therefore, dy by dx is equals to dy by dt and divided by dx by dt. Okay. What is dy by dt? This value 3a sin square t into cos t. And dx by dt value is minus 3a cos square t into sin t. So this 3a and 3a both will get cancelled. Here one cos and here one cos. Here sin and sin. So in the numerator one sin left and in the denominator one cos is left. So sin by cos means tan and here negative sign is there. So dy by dx is equals to minus tan t. Okay. If you don't understand this one directly, one more step you write. This is here sin is there, here cos t is there and negative sign. Okay. Sin by cos is tan, so minus tan t. Okay. So this is the solution of the problem. If they ask one more time differentiation, that is d square y by dx square, here you find one more d square x by dt square. That means it will be in the form of UV rule. So one more time differentiation here and one more time differentiation here, you will get d square y by dx square. Okay. So this is the method for the third method, parametric differentiation. In parametric differentiation, 3.4.8 example is there and 3.4.9. Okay, these two examples you practice. Next, we will go to the fourth method. It is the differentiation of implicit functions. Okay, so in this, the functions will be in such a form that you can't separate the y variable from the given function. So such functions we will use one method, that is a differentiation doing on whole whatever the function is there, that whole function will do the differentiation. Okay, so if we separate the y from any given function, so that type of function is called explicit function. So here, if not separated, then it is called implicit function, and if it is separated, it is called as explicit function. Okay, so we have here implicit function here. So if you think so if it is a explicit function, it will be in the form of like this: x square plus y plus 3 equals to 0. So in this we can separate the y. So y is equals to minus x square minus 3 equal y equals to minus x square minus 3. Okay, that means the y in such a way that we can take it separate and we can find separate the other variables on other side. Okay, now if you do the differentiation of this one, you will get dy by dx equals to, this is minus 2x and this is 0. So you got dy by dx equals to minus 2x. But if you take the problems like this, okay, if the functions are like this, xy plus sin y equals to 3 is there. Okay, so in such we can't separate this one. If we separate, what will happen? Xy equals to 3 is there minus sin y. So y equals to 1 by x of this one, 3 minus sin y. But here also y is there. Okay, so only y we can't separate. Here y is there, here y is there. So in such type of problems, what we have to do means we have to do the differentiation to this whole function directly. That is, it is in the UV form. So x into dy by dx plus y into x differentiation is 1 and sin y is cos y and this constant is 0. So what we will get? X, here dy by dx is there. Sorry, here sin y differentiation is cos y and y differentiation is dy by dx. Okay, so equals to 0. So here dy by dx, here dy by dx. So you can take common dy by dx of here x plus cos y plus y equals to 0. Okay, and here we need the dy by dx derivative, no? So dy by dx of x plus cos y equals to minus y. You have taken that y that side. Now what is dy by dx value? Dy by dx equals to minus y by x plus cos y. Okay. So such procedure if you take and if you find the differentiation of the problems, so such type of functions are called implicit functions. Okay. So we'll see example of one function. So these are also, it is just here separating and doing no. So this is also only 5 marks question you will get. So I will take one example. So the function is ax square plus 2hxy plus by square equals to 1. Okay. Then find dy by dx. Or find the derivative. Anything will be there in the question. So solution for this one is, so you take, let ax square plus 2hxy plus by square equals to 1. Okay, you take this as equation 1. Now you write the differentiation of this one, that is differentiate 1 with respect to x on both sides. On differentiating we get, okay, so this, if you do the differentiation, what you will get? Ax square is there, a is constant here, you keep like that only, and x square differentiation is 2x. So 2 you write here, x you write here, and this is 2h you take outside. Why? Because here 2 variables are there. So 2 variables you have follow the UV rule and you have to do the differentiation. So first you take x constant and y differentiation is dy by dx plus y you keep like that only, x differentiation is 1. Okay, so x into dy by dx plus y, and 2h you have taken outside, and here plus 2by, and constant differentiation is 0 here. Okay, so now here 2 is there, 2 is there, 2. You take the 2 from all these 3 common and you take to right hand side, it will become 0. Okay, so what is left? Ax plus here h is there into x. You take out this one and you multiply with h. So this is hx dy by dx plus hy plus by equals to 0. Here also we have to write, we forgot, dy by dx. Okay, why? Because it is with respect to y, no? So 2by and y differentiation is dy by dx. So by dy by dx equals to 0. Okay, so we need to find dy by dx. Now here for 2 we have the dy by dx, so take common. So what you'll get? Dy by dx, if you take common you will get here hx plus by. Okay, now you write this as separate, ax plus hy equals to 0. Okay, now we need this value, so dy by dx is equals to, or else you can write one more step if you have any confusion, plus by equals to, you take this that side, it will be minus of ax plus hy. Okay, now therefore dy by dx is equals to minus of ax plus hy by hx plus by. So this is the derivative of the given function. So if such functions are there in such a way that we can't separate the y variable, then for whole function we have to do the differentiation. Okay, so whatever the answer you are getting at the last, that is the derivative of the given function. Okay, so by this we are completing the third unit. In third unit, 66 page number 3.4.11 and 3.4.13. These two are the important in fourth method. Okay, so up to third unit and block 1, by this we are completing the block 1. So we have completed all the important questions, and also whatever the questions you are getting for 5 marks question I have told, and even 10 marks questions, and even page number exercise is there. See 68 page number 3.5. In that you take 1, 2 as important questions, and here page number 69, if you'll see, 4th question and 5th question. 4th and 5th are the 10 marks questions. Okay, Fifth question I have told now just, and fourth question is similar to the fifth one. Just you take it in the form of u plus v. Okay. Okay. Fourth and fifth are the 10 marks question, and here 1 and 2 are the 5 marks questions. So these are the important questions from the block 1. Now we are going to the block 2. Block 2 is about successive and partial differentiation. Okay. Successive and partial differentiation is nothing but here, miss here up till now in block 1, we have seen only the first order differentiation. So if we'll go to the continuation doing of the differentiation, that is a first order, second order, third order, up to the nth order, then we call it as a successive differentiation. Okay. So in successive differentiation, the question will be on finding the nth order of the given function. That means d to the power of n by dx to the power of n. So if they are asking the nth order, then it is called as a successive differentiation. And in this, you have the Leibniz theorem is there. So with the help of the Leibniz theorem, how you are able to solve the problems. So nth order question will be the 10 marks question you will get. That is a 10A. 10A question will be from unit 4, and 10B question you will be getting from the unit 6. And in between, whatever the unit 5 is there, that is the Euler's theorem is there, that you will get for only 5 marks question. Okay. So if you go to the unit 4, block 3, so second block, successive differentiation. So here the functions may be in the form of y or f of x, or we can write dy by dx, or what we have seen. So for these all functions, y equals to f of x will be in the form of the function. And for this, if you are taking the differentiation, we have seen that first order will be, so the differentiation of these functions will be in the form of either dy by dx or f dash of x or y dash or y1. Okay. So here if you take second order, d square y by dx square, here second order means this one and this one, and this is 2. So for this, if you go on doing the differentiation of this, you will get here y1, this is y power n, this is yn of x, this is dny by dx to the power of n. Okay. If we'll go on to the differentiation, and if we'll find up to the nth order, then we call this such type of all derivatives are called as higher order derivatives, and the differentiation is called as a successive differentiation. And even we'll write this one dy by dx, no, it has like this also, dy or d square y or d cube y up to dn to the power of y. This d is called as a linear operator. Okay. So even this dy by dx can be expressed as capital D into y. Then next d square y, d cube y, d to the power of ny means 1, 2, 3, 4. This is the 5 methods we can write the differentiation in any form. So in some problems you will have like this d somewhere like this, somewhere like this, somewhere like this, somewhere like this. So the question may be in any form, but the thing is depending on the here degrees, whatever are their order, that depending on that order you have to see whether it is a second order or third order or fourth order, like that. Okay. So but these forms are important, try to remember them, not only in this unit, other units also there may be questions in the form of d, or else like this, or else like this. Okay. So in at the here if you write to the base y1, y2, y3 also, it is also the order of the differentiation. Okay. So in this, the questions whichever you will get for the 5 marks questions are, any one function will be there, and he will ask the higher orders, that is not the first order. He may ask second order or third order or fourth order. So such type of problems you will get only for 5 marks. If he is asking the nth order, then you will get for the 10 marks question. So one example we'll see here, that is if you have like this, if y equals to log of sin x, then find d cube y by dx cube. So he is asking the third order. Okay. So here the order is 3. So for this, you take let y equals to log of sin x and you put it as 1. Okay. So differentiate 1 on both sides. So what you will get? This is 1 by y. Sorry, only y is there. No? So y differentiation is dy by dx is equals to log of x. So here in place of x, we have sin x, but log x differentiation is 1 by, what is x? X is sin x. And again, sin x differentiation is cos x. So it is cos by sin means cot x. It is only first order. Okay. So now you take this as 2. Now differentiate 2. Why? Because he has asked the third order. So differentiate 2 with respect to x on both sides. Okay. So this will become d square y by dx square equals to cot x. What is the cot x differentiation? Cot x differentiation is minus cosecant square x. Okay. Minus cosecant square x. So now we got second order, but he's asking one more order, that is the third order. You take this as equation 1. So again differentiating 3 with respect to x on both sides. What will get? d cube y by dx cube. Okay. So now it is in the form cos square x is there. So x square form. X square form means you take minus like that only 2. It is x to the power of n form. N into x to the power of n minus 1. So here our n is 2 cosecant x. 2 minus 1 is 1. So minus 2 cos x. And what is cosecant x differentiation? Again, we have to do this differentiation also. No. So cosecant x differentiation is minus cosecant x into cot x. Okay. This minus minus will become plus. So 2 cosecant x is, you can write like this or in short form like this, anything. Okay. Both are same. Don't get confusion. Cosecant square x, cosecant x, cosecant x, cosecant square x into this is cot x. Okay. So the third order of this one, first order is given. So first given the function is there. So if you do the first order, you will get one value. If you do one more, you will get one value. If you do the third order, you will get the answer. If he is asking fourth order, so for this only d to the power of 4 by dx to the power of 4 is asking means here it is UV rule. Why? Because two functions are there. Cosecant square is one function and cot x is another function. So you find the UV by taking one constant and you by taking another one differentiation, and second one constant and first one differentiation. If you will get the another order. Okay. So but like this you can find any order from the given problem. So in 76 page number, whatever this problem is there, this is the important one. And even 4.2.3 problem is there, no? So that also you may be getting for 5 marks questions. And even 77 page number, if ax square plus 2x xy plus by square equals to 1, then show that d square y by dx square equals to, that is asking the second order. Okay, here dy by dx you got it in the form of u by v form. If you apply the u by v differentiation formula, that is v square into v into du by dx minus u into dv by dx. If you apply that formula u by v, you will get the solution for this one. So use practice even 4.2.3 problem, 4.2.4 problem. Next, if we'll go to the check your progress, you have if y equals to log x by x greater than 0, then find d square y by dx square. Okay, this is also u by v form. Then you can do the differentiation of that one. Next, if we'll see the third one, 1, 3 and 4 are the important one. If you'll see the third question, is given that if y equals to a sin mx plus b cos mx, then show that d square y by dx square plus m square y equals to 0. Okay. So these are all the 5 marks questions. So if y equals to a sin mx, b cos mx. So find or show that we have, no? Then show that what we have, d square m y by dx square plus m square y equals to 0. That means second order here. Okay. So y is given as y equals to a sin mx plus b cos mx. Okay. So you take it as 1 and differentiate 1 with respect to x on both sides. So what you'll get, dy by dx is equals to, this is sin x. So sin x differentiation is, and here m is there. So m quotient you have to write here. M or am, cos, sin differentiation is cos mx. So here sin x cos mx, and this x differentiation is quotient you have m. So write here m. So this is cos differentiation is minus sin. So mb sin mx. Okay. So this is the first order. If you'll take here m common, what you'll get, a cos mx minus b sin mx. Okay, now differentiate. We need second order, no? So differentiate 2 with respect to x on both sides. So what you'll get, d square y by dx square is equals to, so m you keep like this only, and inside 1, this is minus am sin mx, and this is minus mb cos mx. Now you take m here common. So minus also if we take common, what will happen? Minus m into this m means m square. And here what you'll get, a into sin mx plus b into cos mx. Okay. So what is this a into sin mx plus b into mx means from 1 we got, this is y. So it is minus m square and this part is y from 1. Okay. So this is d square y by dx square. So if you take this side, what will happen? D square y by dx square plus m square y equals to 0. So he's asking to show this one. Okay. So this is the procedure how to find the problem. Even fourth problem is also like that only, y equals to e to the power of minus x cos x. Then show that it is a fourth order is given. So like this continuation, we have to do the fourth order and you have to see that one. Okay. And if you see the 78 page number, you have the nth derivatives of some standard functions. So these you will get for the objective type of questions. That is a 78, 4.3.1, 4.3.2, and 3, 4, and next 5 and 6 also. 6, 7, up to 7, 4.3.7. You should know these all formulas. So then only we can find the nth order of different functions. So after that, you have the examples here. So 81 page number 4.3.10. Next 83 page number 4.4.1. So next class, we'll see one problem from this one. Just you take the important question from this. 83 4.4.1. Next 85 page number 8th question. Next we have the Leibniz theorem. You can take 4.5.4. Okay. Find the nth derivative of log x by x. So these are the important questions from the 4th unit. Okay. So again, 2 classes are there. Those are in January. You have January 7th and 8th. So we'll try to complete the block 2 in that. And we'll already first block I have given the important questions. So at the time of that class, I will give the important questions in second block and third and fourth. Okay. We'll see in the next class. Okay. Bye.
Yes.